Okay, this is Mario once again with MIA Microflight, and as usual, my morning breakfast. I do a lot of sketches and ideas. I put those on paper. In this case, I took this board here. I've been trying to see if I can create a layout at quarter scale of one of the vintage go-karts. In this particular case, the Alley Cat. Now there are a number of people that have taken old alley cats and refurbished them, and some have even done reverse engineering on them. But there are no set of instructions or guidelines as to the dimensions that in full scale. Meaning, I mean, here you may find a couple of dimensions here and there from people that give you that information, but there's no set of plans, not that I have come across. And I have searched quite a bit, to see if I can find some basic dimensions of the vintage go-kart called the Alley Cat. What makes the Alley Cat in particularly interesting is the fact that it is designed in a way that is such that the frame, in this case, this is kind of a similar layout. It's a one-piece frame going from this point all the way around to that point here, where they joined the front axle support, which is another bar that is also bent in a way to give you a sort of a lower section on the wheels, meaning that the frame itself is lower. It's about I don't know, maybe about 3 inches, from the ground, center line with the wheel, and so this is also bent in a specific direction, upwards and rearwards. It tilts rearwards to create what is called the caster. So if we were to look at the front of that section, you would have something like this with a kingpin, meaning that the pin where the axle pivots is on an angle. Typically, that's about 2 to 7 degrees. 7 degrees being the more popular angle for kingpin. So if you look at this sideways from that point, you would be looking at this section over here where the this whole axle that holds the wheels is tilted backwards. And I think that's about 5 degrees inclination, for caster. So that's about typical of all these go-karts that have a live axle. Now, the ones in the old days, they didn't have live axles, at least not for a while, not at the beginning, I don't think. So they were just a straight bar where they drove the, either the left or right wheel only. So in that case, caster was not prominent, and the caster comes in more in line with the live axles, and there's a whole bunch of videos that talk about the engineering behind that, so I'm not going to go too deep into that. I'm just illustrating some of the basic principles in the front section of the go-kart, and this video is more to talk about the particular design, as I am trying to do with without having to weld the frame. And as you can see, these connectors are maker pipe connectors, as I've done already in my more racing style go-kart that you may have seen in some of my earlier videos. I have already done a racing go-kart using EMT tubing, 3/4 inch EMT tubing, and the maker pipe connectors. You can see that whole thing in some other videos. But in this particular case, I'm trying to just keep it simple, keep the frame simple, because the go-kart, the more racing go-karts, more modern ones, as I did with the in my previous videos, it's very complex, and the bends were very, very complex to bend. Some of these areas, to achieve the true modern racing go-kart frame architecture. And so in this particular case, I want to build. I want to go back and build, one of the vintage go-karts using maker pipe connectors, so that it is easier for somebody that's maybe considering building something like this without having to weld it. I did purchase a welder, and I've been playing around with that. but I'm still not totally into welding, and so I think this would be a much better option. You can build a lot quicker, and you can disassemble it and build some other things if you get tired of it. So you can repurpose, a lot of these parts. So that is that's been my focus, in building go-karts, and this is not the only vehicle that I'm building using maker pipe connectors and EMT tubing. So in this particular case, if we want to mimic the vintage alley cat, you would have to have a frame such as this that has a bend right here. And these bends, by the way, are a little more complex on the real one. I'm just trying to keep everything vertical, straight 90-degree connectors. Maybe this is just at a 45 here, instead of having the more angled on the sides as the original alley cat shows. But like I said, there are no dimensions that they give you the where to bend and where to what distance is it, for example, from here to here. I think there's a guy that said that this is about 19 inches in 19 inches in distance where this first band comes in, but there's no dimension, from what the height is here. There's no what kind of die is he using, to bend this curvature here. So I'm having to guesstimate that he's probably using a 6-inch OD die, which that would make it a 3-inch radius die as well. So I mean, you can do that with a pipe bender, just a regular EMT pipe bender, as I have done it, but I modified my pipe bender, and I have a video also on how I modified that pipe bender so that I can put that on a really thick board and mount that board on a post that's solid on a cement base. So I'm going to assume that all these bends right here, where it's rounded, is about a 3-inch radius, which would give us a 6-inch diameter. So 3 inches right there is about right there. So so if we want to do a 3-inch radius, I think I think that would be a nice nice subtle, not too sharp and not too wide of a curve here. It's like I did in some of my, like I said earlier, more racing style frame using maker pipe connectors and EMT tubing. So the this particular bend right here on the alley cat and some of the similar go-karts of the yesteryear were done to raise the axle height more in line with the front end, because the front end is also bent upwards. It's also bent upwards as let's see if I have a sketch here. Almost like this one right here, it's bent a little bit on an angle upwards, and it tilts to the back, like I said, to create the caster. And so in order for this frame, this section here, to sit lower, have a lower center of weight, you can do this setup here, where it raises the frame support for the axle at the rear. And so this becomes more in line with that, with a lower section right here, and the bucket seat, which also sits underneath here, also gives you a lower what they call center of gravity. I don't like to use gravity. That's another topic for another video. I like to use center of mass, or center of weight. So that's how the alley cat is pretty much set up. And so in order to do this with maker pipe connectors, these would have to be just 90-degree or 45-degree here, 45-degree there, bend, and a 90-degree right here. And if we use this as one complete piece of tubing, the tubing comes in 10 feet EMT, 10-foot tubing. If we were to follow some of the basic dimensions that I think this should be at, I think this is about 20 inches, as I recorded from another guy that builds go-karts from scratch and tries to replicate these things. I think he said it's about 20 inches at the back and 20 inches in the back and 16 at the front. So as you can see this layout right here, I kind of did that following his basic dimensions, but those are all the dimensions he gives you a height for the steering wheel, and he gives you a dimension from the back seat to the center line of the steering wheel where it engages into the drive shaft. But that's about it. I mean, he doesn't get too specific about the dimensions that you really need if you're going to do this, from scratch. So that's what I'm trying to do here, is trying to figure this out. Now, I've done go-karts in true scale, to the racing go-karts on the computer. So I have those dimensions, and I guess I could take those dimensions and then kind of follow those basic dimensions, for the more racing go-karts and try to build up all the other dimensions from there, because the most important dimensions are axle to axle distance, from here to here. I think on mine is 42, but in that other gentleman that did that is recreating these vintage go-karts, I think he said it was about between 43 and up to 45, for really tall guys. I'm 5'11", so for me 40, I think it's 42 or 43 on the one on my more racing go-kart. So I'm going to go with that dimension, from here to here. So that's an important dimension. The other dimension that's important is the width of the kingpin to kingpin distance right here. And that on mine, I think it's about the same as this gentleman had here. He said it was about 26 inches, and I think I made mine 26 as well. And I think I got those dimensions from a more racing go-kart when I started scaling down from a photograph, on the computer. I just took the photograph. I had the top, front, and inside photographs or real racing go-kart, and then from there I popped it on the computer, and then just taking into account the size of the driver being about six feet, I started to dimension everything from that point of reference, and that's how I got my dimensions for my racing go-kart. I mean, I could do the same thing here. I guess I could do that, but I'm trying to do this on paper as I'm having my breakfast, as I typically do in the mornings. I tend to sketch out things because I'm always my mind is always working, and so that is an important dimension. This, we can say that this is about that if we want to keep it just nice and parallel throughout with no specific weird bends as the original Alley Cat has. It's got the side bends. So it's a little more complex geometry to bend these tubes. I'm just going to keep it nice and straight here. So I'm going to say about 20 and 20 at the front and at the back, so everything's parallel here. So the only bends that one would have to do if one were to manufacture this using maker pipe connectors would be just to take that aluminum tubing. You do need a reference line here, a center line, and that's important, because that's where you want to establish all your dimensions. You want to measure from the center line. Once you get that, everything else is symmetrical from that point on. So if we were to break this 10-foot or divide this 10-foot EMT tubing, typically I would measure at 5 feet of the EMT tubing, make some kind of a jig on some plywood or board, old table, whatever you have, and draw basically this pattern here, and then figure out how much EMT tubing I'm going to need to do these this section here. So let's assume that this is 20 inches. So you got about 10 inches here coming into this corner of this bend. Of course, when you do bend, it takes a little more material, and then you can figure out through via math or just using a bender. And once you figure out how much you need to bend, using a scrap material, you can figure out how much actual material it took to do that bend. but let's just say it's about 10 here, 10 here, from here to here. Let's just say it's another 10 inches. So we're talking about 10, 20 from here to here. Let's say it takes about another 10 inches. So we're talking about 30 from here to here, another 10, 30, 40 from here to here. Let's say it takes another 8 or 6 maybe. So that's 40, 46, 46, 46, 46, 46, and from here to here another 20, 46, 66 inches. So we're talking about 66 inches, 66 inches from this center line of aluminum or EMT tubing. So 66 inches times 2, because you're going to do the symmetrical side on this side. So that would be 100. So that would be 100. Am I doing this right? Let's see. 2 times 6 is 12. Carry 1. 2 times 6, 12. Carry 1, 13. Yeah, that would be 132 inches. And 10 foot times 12 equals 120 inches. So I'm a little bit off here. So by 12 inches here, by a foot. So I need to reduce that somewhere here. And I think I think I did this maybe a little bit. I got a little carried away here in my dimensions, but when we start measuring this, I think the 10 foot will do just fine in this setup here. And I think that's how I did my go-kart, also my more race style go-kart. I took a 10 foot piece of tubing and I bent the back, to do exactly that, as a one piece. So that it's a little more rigid and you don't have too many couplers, coupling things and piecing things together. But I think with a 10 foot section, you can do this section right here just fine. And then, of course, the front, that can also be bent as it's kind of a U shape. And that's probably, you can just take that from I think that dimension might be 26, maybe 28, with these bends here of tubing. So, that's close to 2 feet, 2.5 feet. And these sections right here can be also done, just with scrap pieces of tubing. The seat can also be done with, a partial 10 footer. And you might be able to get this, and this for the seat out of another 10 foot. So we're talking about maybe 2 10 footers, 3 footers if you want to do the bracing here, because you're going to need some bracing here, to brace it and keep it all parallel. So that is my take, just from a rough standpoint, as we're looking at this these ideas that I've been putting on this board here. And I've been playing around with the design to see if I really want to go with this this bend here right here, which establishes the higher height of the axle here, and basically just to drop the seat lower, or just go with a flat, go more with a flat section right here where everything's connected. On the there are no raised sections for the front or for the rear axle. Just go with flat, and then this section right here would be just what I'm doing right here. So more like this one. This would be a lot easier to build. The only thing with this is that you're going to have the height between the wheelbase and the frame itself is going to be a lot higher here than something like this, where you have the bent axle at the front, which lowers the frame, and so you have a much lower frame. So this looks a lot better, a lot cooler. It's better for handling the car, because you sit it just sits better on the ground, because all your weight is lower. The higher the weight, the less stable it is. The lower the weight, with reference to ground, the more stable your car is going to be. And there's so many things that you can do, angles and bends, to further stabilize not only the static the static weight, or the static stability of the car, but also you can do it dynamically. When you were talking about dynamic stability, now we're talking about angles um, and distances and weight distribution of the wheel to wheel, a distance from front to back. All that plays a role in stability of the go-kart. And a lot of that has been done, through the years by experimentation, just by, having one that wasn't stable. The early cars were not stable because they were so narrow and they would tend to tip over, on corners. And so, once you experience that and you begin to understand, what can you do, to make it more stable, make the wheels wider, um, make that distance from axle to axle a little bit longer. Then you can start playing around with different kingpin inclinations, caster, camber, Ackerman. I mean, there's so many things that as you get into the design of a go-kart that you will learn, as I have learned. Nobody comes into these things with all this information. We all learn from somebody else, and I've been spending a lot of time. When I did my first go-kart, I spent a lot of time learning these things because it's something that they don't teach you in school. You can get math, you can get um, physics, you can get engineering principles, but when you design real things, you have to understand the mechanics of that, and that's a very dedicated field that you either go and study that. You can study engineering, take further courses, study true engineering for racing cars, or for helicopters, or for aircraft. You can study that, or you can do it as with real hands-on experience and experiments. A lot of the stuff that I know about aircraft is, I never went to school to study aerodynamics, but I do have an engineering background in electronics, and my experience with aircraft was a lot of common sense that I learned, by building things and seeing what works and how things behave. And so that in itself is it's gold in my opinion, as far as information, because you're actually practicing, what you're building. You're actually experimenting and getting feedback direct from what you're building, and so that is good information, because you know exactly what works and what not, what doesn't, by doing things, and you understand things better that way than just having a lot of theory and seeing photos and pictures that don't really do you much until you start building things and you start getting real, tangible information and feedback, like I was saying. So, getting back to this car, getting back to the materials that you would need, I'm trying to keep it very simple. So I think this would be one way, but this would be a lot easier here, just to build a frame that's flat like this, and even here, building it flat, we can put a bracket here that raises it, that kind of mimics the height distance of this bracket right here, with this frame being bent. So in order to avoid the bend here, we can put a higher bracket here and bring the and lower the frame. Same thing here. We can certainly do this front steering bar right here on this one here. So I don't think that's too big of a deal, because it's just very shallow bends here, and you're still going to need to do the brackets here and establish your kingpin in inclination and camber. So that's just a must, especially with a full live axle drive system. But the frame itself is very, very simple, and we're not using that many components here as far as the brackets are concerned, because although maker pipe connector brackets are less expensive than some other brackets that you can buy at the Home Depot, a hardware store, they can get a little hefty in price when you start using a lot of them, as I did with the go-kart that I built, because there's a lot of brackets. It's a lot of more complex frame. So if we keep it very simple, that's one way to do it, and just for ease of building for the average person that doesn't have a lot of tools. And I mean, you can cut EMT tubing with just a pipe cutter, real easy. Especially if you just put the pipe, just go one way and then you just keep going that way and just let the cutter do that. Tighten the cutter and it cuts real easy that way. You don't need a grinder. You don't need a welding equipment. So I think this is one way that I'm going to do it. The back seat, it can also be bent real easy, just a U shape with a bracket right here and a bracket right there. On my go-kart, more racing go-kart design, I added 2 brackets here, and you can see how that's done, via my videos, how I did that with the maker pipe connectors. And so I'm kind of leaning towards this particular frame, very simple frame design here for a go-kart, but making sure that we include all the required angles here so that your car steers well and it performs. I mean, we're not building professional go-karts here. This is just more for fun. And so I think this is one way that I'm going to do it. The next thing I'm going to do is I'm going to fully build this out of brass tubing. I'm gonna solder it to mimic the welds for one frame if I wanted to weld that. But I'm also going to build this one with maker pipe connectors in miniature quarter scale, which I designed, and I can print those in my 3D printer, and that'll mimic as well this particular frame design, or this one. So this is the size, as you can see. That's my hand in comparison to a 1/4 inch scale go-kart. So this would be the frame basically of the go-kart. That size right here. So we're talking about a good size car. If you wanted to do quarter scale too, the way I'm going to do it, and I'll show that in some other videos with a 1/4 inch tubing to mimic a 1 inch pipe or 1 inch tube as is used on the full size go-karts. Anyway, this is Mario with MIA Microflight once again, and this is what I do in the in the morning when I am having breakfast. Stay tuned for more.